In this lecture, let's discuss about finding the rank of a matrix by normal form or canonical form. So in this normal form or canonical form, we basically have 2 points. The first point, row and column operations are allowed. The row operations include R1 minus R2 equals to R1 or R1 plus R2 equals to R3, R2 minus R3 equals to R3 or R1 swap R2. All these operations include under row operations, and the column operations are C1 minus C2, C2 minus C3, or C1 swap C2. Like these operations are column operations. So these operations are allowed in this normal form. And the second point, by applying elementary row and column operations, we reduce the given matrix into identity matrix. So there will be a matrix given to you. So by applying several row and column operations, you need to reduce that matrix into identity matrix. What is an identity matrix? A matrix in which the diagonal elements are 1 and all the other elements are zeros is known as an identity matrix. So by applying rows and column operations, we need to reduce the given matrix into identity matrix. That is the second point. Rank of the matrix in normal form. The order of the identity matrix is called the rank of the matrix. The order of the identity matrix will be equals to the number of ones in the diagonal. Okay, so I'll explain you with an example. Let's consider a matrix 1 0 0 0 1 0 0 0 1. Now consider this matrix. This is an identity matrix because in the diagonal we are having ones and all the other elements are zeros. So this is an identity matrix. So in the diagonal we are having 3 ones. So the order of this matrix is 3, and here we have the order of the identity matrix is called the rank of the matrix. So the rank of the matrix also 3. Okay, and let's take another example. 0 0 0 0 0 0 1. Now consider this matrix. In this matrix we are having 4 ones in the diagonal, in the principal diagonal. So the order of this matrix is 4, and hence the rank of this matrix is also 4. And now let's discuss this normal form using an example. Okay, so here we are given an example matrix, and we need to reduce the following matrix into normal form and find the rank of the matrix. So for reducing this matrix into normal form, we need to perform some row and column operations on this matrix, and we need to convert this matrix into identity matrix. In identity matrix, here in all the diagonal values should be equals to 1, and these upper values and lower values below the diagonal should be 0. In the first column, these 3 values should be 0, and in the second column these 2 values and this one should be 0. In the third column, these 2 values and this 5 should be 0, and in the fourth column all these 3 values should be 0. R2 minus R1, so R2 equals to R2 minus R1, that is 1 minus 1, then we'll get here 0, then 3 minus 2, we'll get 1, 2 minus 1 will get 1, and then 2 minus 2 will get 0. So I'll take another matrix here. This row will be same 1 2 1 2. Now 1 minus 1, that is 0. Here we'll get 0. 3 minus 2, that is 1. Here we'll get 1. Here 2 minus 1, that is 1. And next 2 minus 2, we'll get 0. And next let's come to the third row. Here we have 2 and here we have 1. So we can write R3 equals to R3 minus 2R1. Here we are having 2 and here we are having 1. So we need to multiply this row with 2 so that this one becomes 2. Then 2 minus 2 will become 0. That is 2 minus 2 into 1. 2 means 2 minus 2 equals to 0. Then 4 minus 2 into 2, 4. Then it is also 0. Then 3 minus 2 into 1, 2. 3 minus 2 equals to 1. And next 4 minus here 2 into 2 equals to 4, that is 0. So I'll write here the operations which we have performed in this matrix. First we have performed R2 equals to or gives rise to R2 minus R1. Okay, and the next operation R3 gives rise to R3 minus 2R1. And now we have the fourth row. Here we need to perform. Here we are having 3 and here we are having 1. So R4, sorry, this is R4 and this is R1. So R4 minus 3R1 equals to R4. Let's write the row operation, that is R4 gives rise to R4 minus 3 R1. Okay, yes, 3 minus 3 into 1, that is 3. And next 7 minus 3 into 2, 7 minus 6, that is 1. And next 5 minus 3 into 1, that is 3. 5 minus 3 equals to 2. And next 6 minus 3 into 2, that is 6. 6 minus 6 equals to 0. And we have 2 and here we are having 1. Let's make this one as 0 first. These two and this one. So C2 minus 2C1. Okay, I'll take the next matrix. The C1 will be as it is, that is 1, 0, 0, 3. Now C2, here I'll write the command or the operation. C2 gives rise to 2 minus 2C1. Okay, Mm. 2 minus 2 into 1, 0. Next, 1 minus 2 into 0, that is 1. Next, 0 minus 2 into 0, 0. Next, 1 minus 2 into 3, that is minus 5. So I'm sorry, here I made a mistake. Here we have R4 minus 3R1. R4 implies R4 minus 3R1, that is 3 minus 3 into 1, that is 0. Here we'll get 0. This is 0, and here also we'll get 0. And what is the common? We have C2 gives rise to C2 minus C1. So we are having 1 minus 2 into 0, that is 1. Okay. Mhm. And next, what can we do? Here we are having C3. C3 minus 1 minus 1, 0. So we can make C3 implies C3 minus C1. That is 1 minus 1, 0, 0. Next, 1 minus 0, that is 1. Next, 1 minus 0, again 1. Next, 2 minus 0, that is 2. And next, we have C4. Here we are having 2, and here we do have 1. That is C4 implies 2C1. 2 minus 2 into 1, that is 0. Next, we have 0 minus 0, 0 minus 0, all this. We get zeros. 0, 0, 0. And next, here we are having 2, and here we are having 1. We can make this as 0 by R4 minus R2, that is 1 minus 1. Now we can apply R4 minus R2. Even the second matrix, even the second row will be as it is. 0, 1, 1, 0. Even the third row will be as it is. 0, 0, 1, 0. And the fourth row, what is the command? R4 implies R4 minus R2. So 0 minus 0 minus 1 will get sorry R2, right? 0 minus 0, 0, 1 minus 1, 0. Next 2 minus 1, 1, 0 minus 1, 0. So now we can eliminate this one by performing R2 implies R2 minus R3. Means 1 minus 1, it becomes 0. Let's write the operation. R2 implies R2 minus R3. So I'll be writing the next matrix here. That is, first row will be same, 1, 0, 0, 0. Second row, R2 implies R2 minus R3 means 0 minus 0, 0. Next 1 minus 0, 1. Next 1 minus 1, 0, 0 minus 0, 0. Next the third row is same and also the fourth row is same. And or we can perform another operation so that we can eliminate this one also, like R4 equals to R4 minus R3, 1 minus 1, it will become 0. I'll also write the same command over here. R4 implies R4 minus R3. Write the same values for R3, 0, 0, 1, 0. Next we have R4, 0 minus 0, 0. Next 0 minus 0, 0. Next 1 minus 1, 0. Next 0 minus 0, 0. So here you can observe that in the diagonal elements we have 3 ones and all other values are zeros. So this is an identity matrix. So here we know that the rank of the matrix equals to the order of the identity matrix. Here we have 3 ones, so the order equals to 3. Order equals to 3. Rank equals to 3. I hope you got the whole process. For this matrix, we perform these operations and we got this matrix. And for this matrix, we perform these operations and we've got this matrix. And for this, we perform this row operation and we've got this. For this, we perform this and we got this. Okay. Thank you for watching this video and subscribe for more useful videos. Thank you.